confidence intervals and sample size for proportions. So this is the third lesson in the unit. Before this, we went over confidence intervals for means, and we did it for a couple scenarios, large sample size and small sample size, and whether or not we knew the sigma or not, the population standard deviation. Here we're going to focus on proportions, what a proportion is, and how to find the confidence interval, and how to find the sample size given certain conditions. So let's begin with proportion. The concept of proportion represents a part of a whole. It can be expressed as so it's basically like a fraction, so it can be expressed as a fraction, decimal, or a percent. Proportions can also represent probabilities, and remember that probabilities can be expressed as either of those three forms as well, fraction, decimal, or percent. And you can obtain proportions from the sample or the population. So there are symbols that we use for the sample or proportion. So the population proportion is given by P. The sample proportion is given by the symbol P hat. Okay. In any case, to find, like for example, P hat, you're going to take the number of people or sample units and then divide by the total number. So like for example, if you're interested in people that are, or if you're interested in the proportion of red Skittles, like in our Skittles lab, you're going to count the total number of Skittles that's on the bottom, and then the numerator is the ones that are red. So that's a proportion. So let's look at an example. A random sample of 200 workers found that 128 drove to work alone. Find P hat and Q hat, where P hat is the proportion of workers who drove to work alone. So we got a sample of 200 workers. So that goes on the bottom. And then we want the ones that drove to work alone. So that's 128. All right, so that's your proportion. And we'll convert it to a decimal. And you get 0.64. All right, and then the Q hat is going to be the proportion of workers who did not drive to work alone. So the opposite, okay? So in order to do that, you can do minus P hat, right? So 1 minus 0.64, which is 0.36. All right, very simple. So it's just calculating, a fraction or a proportion, or decimal. So just like with means, point estimates and interval estimates for a population proportion can be made using the sample. So using the sample proportion. So remember that the point estimate for the mean, so the point estimate of mu was x bar. This time, the estimate of p is going to be p hat. So the best point estimate of p is going to be p hat. Confidence intervals for p are constructed using the formula below. So you're going to look at the formula, just like we had a formula for a confidence interval. For means, we're going to have a very similar formula for proportions. In order to use this confidence interval, you have to meet the condition that the NP has to be greater than or equal to 5, and the NQ has to be greater than or equal to 5. So you may remember this from whenever we were doing the binomial stuff, approximations and all that this has to be greater than 5. Okay, so as long as this is true, you can go ahead and use a confidence interval. Oh, and this guy, this So this is, familiar. That's normally your x bar, right? Remember that in the other formula you had x bar plus or minus z alpha over 2, and then you had sigma over square root of n, right? In this formula you have p hat instead of x bar plus or minus your z, and then remember that this term right here was called your margin of error. That's called your margin of error. Remember that this term here that I circled is called your standard error. All right, and remember the x bar is your point estimate. So in this case, this is my point estimate, right? We'll just call it PE for short. And this part right here, the square root term, this is my standard error. We'll call it SE for short. That's my standard error. And then this is my marginal error. And I'll just call it ME for short. Okay, so remember, the only way you can convert a point estimate to an interval estimate is to add or subtract the marginal error. All right, so now that we got the formula, we can talk about the assumptions. The assumptions for finding a confidence interval are that, well, we assume that the sample taken is a random sample. Okay, you usually have to have a random sample for the result to be, statistically significant. The conditions for a binomial experiment are assumed to be satisfied, because remember, since we are dealing with proportions and decimals and probabilities, this means that we are dealing with a binomial experiment. So the conditions have to be satisfied in order to use this. You must also check that the NP is greater, the NP hat, they should say P hat, greater than or equal to 5, and Q hat greater than or equal to 5. We already mentioned that in an earlier bullet. All right, so let's look at an example. So a survey conducted by Sallie Mae and Gallup of 1404 respondents found that 323 students paid for their education by student loans. Find the 90% confidence interval of the true proportion of students who paid for their education by student loans. So we have our N, which is our sample size. It's 1404. We have our X is 323. That's how many students paid for their education, so we can calculate the P hat from this, right? The P hat is the X over the N. So that's 323 that paid for their education with a loan over that many in total. And we'll get that as a decimal. So you have 0.230. All right, so that's our P hat. We had to check to see that N times P hat is greater than or equal to 5. And the same for this guy. All right, so 1404 times 0.23 is definitely greater than or equal to 5. So we don't have to worry about that. And 1404, remember to find Q hat, we're simply going to do 1 minus P hat. So this will be 0.670, which checks out. It is going to be greater than or equal to 5 if you type that in. Okay, so we can go ahead and proceed with doing the confidence interval. Now we want a 90% confidence interval. So since we want 90% confidence, this is my confidence level. That means my alpha is 10%, which means my alpha over 2 is 0.05. So we need to find the area on the z-chart that corresponds to 0.05. All right, so then we go ahead and look this up on the chart, 0.005. All right, so you're going to look up 0.05 on here, and this seems to be the closest number. So we'll choose 1.64 for our z-score. So our critical value, z alpha over 2, is 1.64. So now we can go ahead and plug this into the formula. So it's p hat plus or minus z alpha over 2 times square root p hat q hat over n. So this is the formula that we had written here. You can also write it in interval form, but I like to write it in the plus or minus form. All right, so we can go ahead and plug in the numbers. So we have 0.230 plus or minus 1.64 square root 0.23 times 0.67 divided by 1404. Right, and then you can go ahead and calculate the confidence interval. And you can do this all at once on the calculator. But you just have to be careful with how you type it in. Okay, so for the small number, I got 0.213, and we're going to try to do these in 3 decimal places for the proportions. .247. All right, and that's your confidence interval. So this means that with 90% confidence, the population proportion, or the true proportion of students who paid for their education by student loans, is roughly between 0.213 and 0.247. All right, let's look at another example. A survey of 1,898 students with lawns conducted by Harris Interactive Poll found that 45% of the adults said that dandelions were the toughest weeds to control in their yards. Find the 95% confidence interval of the true proportion who said that dandelions were the toughest weeds to control in their yards. So we have our sample size, 1,898 adults. And it said that 45% of them said made that claim, so we're going to call that p hat. So of that sample, we have 0.45 made that claim, which means that q hat, which is 1 minus that, is 0.55. So if you were to test whether p hat times n is greater than or equal to 5, then this is definitely going to be greater than or equal to 5, because this is 854.1. All right. And if you were to do it the other way, it would also check out greater than or equal to 5. All right, so proceed with the confidence interval. We know that alpha here is 5%, because we have 95% confidence. which means alpha over 2 is 0.025, which means we can proceed to find our z alpha over 2. We have 0.025, which is 1.96, and that's for 0.025. And we can go ahead and plug it in. Remember, that's our formula. So we have 0.45 plus or minus 1.96 square root 0.45 times 0.55 divided by 1898. Okay, go ahead and calculate that. So I have 0.471 for my upper limit, 0.429 for my lower limit. So that means the true proportion, with 95% confidence, the true proportion who said that dandelions were the toughest weeds is somewhere between 0.429 and 0.471. So about between almost 43% and 47%. All right, the next thing we're going to do is talk about the sample size. So that's our next learning goal. Is to be able to determine the sample size given a few conditions. So this is the formula for the sample size. Again, you get this formula straight from the margin of error. So like the margin of error, which we'll call E. So E, we'll call E the margin of error. The formula for the margin of error is given by the Z alpha. Here, let me erase this. It's given by the Z alpha over 2 times the square root P hat Q hat over N. So that's the margin of error for proportions. And then we simply solve for N. And that's how we get that formula. So if we solve for N, then we get the formula for minimum sample size. All right, remember that you're always going to round up if you get a decimal. So there are two situations to consider. The first situation is that you know what the p hat is, so then you would simply plug it into the formula. The second condition is, or second situation, if you don't know what p hat is, then you should use 0.5 as your p hat. Okay. So if you don't know what that is, use that as your p hat to be conservative with your estimate. All right. So a researcher wishes to estimate with 95% confidence the proportion of people who own a computer. A previous study shows that 40% of those interviewed had a computer at home. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary. So it wishes to be accurate within 2%. So that's your E. So your E is 2%, which is 0.02. So you want a 95% confidence, which means your alpha is 0.05, so your alpha over 2 is 0.025. Look that up on the chart, and you get your Z alpha over 2 is 1.96. It says 40% of those interviewed had a computer at home, so that's your P hat according to a study. And your Q hat is 1 minus that, which is 60%. All right, and we want to figure out the minimum sample size. So we're going to use the minimum sample size formula up there. So we have 0.40 times 0.60 times our Z alpha over 2, 1.96 divided by E, 0.02 squared. quickly calculate that. Okay, so I got 2,304.96, which is, we're going to round it. We always round it up, so 2305. So always round up. So that's the minimum sample size that we need for the study for this particular confidence interval. Now switch it to the same example, but this time there's no previous study done, so we have no idea what p hat is. So p hat is unknown for this problem, which means that we're going to say p hat is approximately 0.5, which means q hat is approximately 0.5, and we're going to plug in everything else the same. So we have n equals 0.5 times 0.5, 1.96 divided by 0.02 squared, and then this time we'll get our new sample size. So we have 2,401 for our sample size. So the downside of not knowing what your p hat is that your sample size is generally going to be larger. So this is not good if you're trying to do an experiment and you want to get the sample size to be small, right? Because the idea is you want to get as small a sample as possible, yet getting an accurate result. So so if you don't know what your p hat is, then the downside is you need more people in your study. All right, that's it, guys. So hope you found this useful, and I will see you next time.